And we're going to look in pre-calculus, you look at it from a very specific function perspective. So you look at it as a function and you have some like domain and range issues. We're really, in Algebra 2, we're going to focus on it from an applications perspective, so how we can use it to solve for like side lengths and angles in a triangle, and that would apply to like a lot of real world scenarios. But the key here is now we're doing the inverses. Okay. Which inverse, if you think about in math, I always talk about inverse operations. What is the inverse of addition? Subtraction. What is the inverse of multiplication? Division. What is the inverse of a square? A square root. So inverses in algebra, when we're talking about operations, they're things that undo each other. They work backwards. So these are the basic trig functions on the left. Okay. Sine, cosine, tangent. And we know SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay. And with basic trig, okay, you put in an angle and you get a ratio. And sometimes it's a problem like you were doing on that very first worksheet where I can give you the angle that is a special angle on the unit circle. Like I can ask you to do now the sine of 225 degrees without a calculator, and you can figure out the reference angle and draw the triangle and give me negative square root 2 over 2. I can ask you to do like the sine of 230 degrees, which has a reference angle of 50, and you don't know that triangle, so you would have to pull out your calculator and you would type sine 30 in your or sine 230 in your calculator and give me the decimal that the calculator gave. Or there were those problems where we actually had the triangle, like maybe there was a point on our terminal side and we drew the sides of the triangle and found the radius, and then we don't actually know what the angle is, but we can make the ratios. But the key here is your answer is a ratio. Inverse trig says the inverse sine of opposite over hypotenuse is theta. The inverse cosine of adjacent over hypotenuse is theta. Or the inverse tangent of opposite over adjacent is theta. So it's working backwards. Instead of putting in the angle and getting out the ratio, it's like we know what the ratio is, tell us what that angle was. And your brain was sort of working that way on that last page, right? Like if I said the sine of theta is 1/2, you're thinking, okay, that's a positive sign, so it's in quadrants 1 or 2. Get a sine of 1/2, that would have to be the 30-degree reference angle. So I'm talking about 30 degrees in quadrant 1 and 150 degrees in quadrant 2. So you're kind of working that way. You put in a ratio, you get out a theta. Now notice you finally will get to use the second button on the calculator, right? So remember those inverse sine, inverse cosine, inverse tangent right above those. Those are not for reciprocals. Cosecant, secant, and cotangent. You have to do 1 divided by sine, 1 divided by cosine, 1 divided by tangent for those. But if you know the ratio and you're trying to get the angle, you can hit the inverse button. There is a second notation, so I want to put this on here. There is a second notation for each of these inverses, so just in case you see either one. Inverse sine can also be written like this. Arc sine. Just has ARC in front of it, arc sine. Or arc cosine. Or arc tangent. So just be aware that if you read or see or someone is talking about an arc sine, arc cosine, arc tangent, they're just saying the inverse. It's another way to do it. So the two notations are exactly the same. Arcsine, arccosine, arctangent. Okay, and key piece here is don't put in angles, put in ratios, and then you get out angles. If you're using your calculator, you'll get out whatever angle you have your calculator in. So I'm going to say most of you will want angles in degrees. Okay, so if you can make sure your calculator is in degree mode, and if you'll type these in, I'll put my answers up, and I just need you to make sure your calculator actually works. So can you verify that you get these angles? Raise your hand if your calculator is not giving you the same angle measure. Then you might be in the wrong mode, or we might not be hitting the second button. We want to make sure everybody's calculator works. So notice that those decimals that you're putting in, negative 1.5, that's your ratio, okay, of side lengths. So this is like the ratio of opposite to adjacent, whatever you put in. Negative 1.5 is negative 3 halves. So maybe it was really 3 and 2, but maybe it was 6 and 4, okay, or 30 and 20. But it simplifies to be negative 1.5. That was the ratio. Same here. This would be the ratio of opposite to hypotenuse as a decimal. The ratio of adjacent to hypotenuse. Okay, so finally, we can find a way, like if all I know about this right triangle is that this angle is 90, and I know these two are acute. Are they 45, 45, 30, 60, 40, 50, 10, 80, 1, 89? I don't know what they are, I just know they add to 90. Now we can figure out what that angle actually is. Okay. So you should have done this kind of work in geometry, right? It's like we're in a movie. Sorry. That's the exact sound they use in the movie theater thing. That happened to me in class on Tuesday. I take class on Tuesdays and Thursdays at UNO. And I was sitting on my coat pocket where my phone was, and I could feel like a buzzing. And I was like, whoa, I left my phone on, like, vibrate, So then I was, like, reaching in, and then it started making noise, and it was my snow day nap alarm at 5:45 p.m. So on snow days, I take a nap and I wake up and it was going off and it was like, it's 5:45 p.m. And I'm like, oh my gosh, in my class. And I'm that like old lady that can't work her phone fast enough to get it shut off. Oh man. Okay. It was embarrassing.
Yeah, that's my snow day alarm.
That's your snow day alarm? Okay. So you probably remember doing this in geometry. If this is the theta you're trying to find, this side is opposite in relation. This side is hypotenuse. So essentially you could set up an equation like sine theta equals 7 over 12. But you're trying to find that actual angle. So theta is the inverse sine of 7/12. Some of you might think about, how like it's like if I had x plus 4 equals 3, then I had minus 3 from both sides. You can also think about it like you are inverse sining both sides, right? What you do to one side, you have to do to the other. but you rewrite it as an inverse. And then you type that in, and like I said, these are going to be more like some geometric triangles, so you're probably going to want it in degrees. You'll probably feel most comfortable with that. And what do we get? 35.69. Okay. So if you find that angle, then you can find the last angle by subtracting everything from 180. You can find the missing side using Pythagorean theorem, because you know two of the sides. You could say 144 equals 49 plus x squared and find this missing side. So that would be like solving the triangle, finding all the missing things. And then just as an FYI, some of the questions on the homework are probably going to be word problems. Okay. So kind of like that Ferris wheel problem that was on that first worksheet. It's good to take the time to read it and try to like draw a picture, label the stuff. It shouldn't be like as easy as the last problem, where it's like, oh duh, inverse sine of 7/12. Maybe I have to think a little bit more. Maybe I have to come up with a plan, right? So a truck-mounted crane has a 200-foot arm whose lower end is 5 feet off the ground. The arm has to reach the top of a building 130 feet high. At what angle should the arm be set? So maybe you've noticed I went into Google and just Googled an image. I guess I could have went right outside and took a picture of a truck-mounted crane we might have out here for construction. Just to kind of like put it in perspective, right? So the crane is mounted on the truck so the truck can go around to different sites, and then the different construction sites can use the large crane. So here's my truck. Grab like something like that. Okay, and the crane is 5 feet above the ground. Okay. So I'm labeling that 5 feet. Okay, and I've got my crane, something like that, right? It's a rough drawing, it doesn't have to be beautiful. The arm has to reach the top of a building that's 130 feet high. So I'm imagining this scenario. You know, we're working with Trig, so we're looking for a triangle. Hopefully you can see, here's my hypotenuse. Okay. And then the one thing you would want to be careful in this image is there's that 5 feet again that we are above the ground. We've had that before for like our line of sight. We've had that for the Ferris wheel problem where we got on 10 feet above the ground. So my right triangle is actually formed 5 feet above the ground, which means this vertical side of my triangle is really how high? 125. So you might have to make some extra adjustments for where your triangle is situated in your scenario. And then it says, at what angle should the arm be set? So obviously, like the arm is attached to the truck, we're going to be controlling this angle of elevation right here. So we want to know what's that theta. Oh, and we know it has a 200-foot arm, so we got this piece right here. So it looks like we would use which trig ratio? Sine. Yeah, you've got the opposite, the height that we need to reach, 125, and we've got the hypotenuse. So theta is the inverse sine of 125 over 200. Okay. Delaney.
So even when you do the inverse, the ratio stays the same, even like because you're changing sine to sine, like the ratio doesn't change to like cosine or anything like that.
No. Okay, so This is just doing sine backwards. So normal sine is to do the sine of an angle and get out a ratio. But we're just working that backwards. It's still sine, it's still opposite over hypotenuse. But instead of getting the ratio as our answer, our ratio is our input. And then our output is the angle. So in order, I probably don't give you any problems because, you don't have a cosecant, secant, or cotangent button. But in order to do the inverse secant, inverse cosecant, inverse tangent, you've got to rely then also on that whole reciprocal part that you would do 1 over the ratio. So you would do the inverse sine of 1 divided by the given ratio, and that would be your inverse cosecant. But for these, I'm probably going to give you the basic 3. Any questions? Okay, when I come around and check homework on Monday, I'm going to want to see if there's a word problem. I'm going to want to see a picture or a drawing. It shouldn't just be left blank. I didn't know how to do it. If you didn't draw anything, you probably didn't try it. So don't be lazy on that. You're doing the back side. So you're going to have pages 1 through 4 done. The very last page isn't, we won't do that till Wednesday of next week. So the law of sines and law of cosine.